I'm going to do the examen VWO 2022, Tijdvak 3, period 3 in English. The first question, there's a function f given by this expression here, and capital F of x given here is the primitive. And bewijs dit means prove it. Okay, well, the primitive of 1 over x is log x. So we see here it's somewhat of the form. It's 1 over x minus 5. So you should try log x minus 5. And since the derivative of x minus 5 itself is 1, if you do the derivative of this and apply the chain rule, the kettingregel, then you find just 1 over x minus 5. So you get f of x is log x minus 5, and for the other one simply log x minus 6. And property of algebraic property of a logarithm is that the sum of two logs of the same base is actually the log of the product. Oh, this is log x minus 5 times x minus 6, which is log x squared minus 11x plus 30, which is the given function. What you also can do is just take the derivative of this and prove that it's equal to f of x. Question 2. Here we can have our function f, and two areas phi and w are defined beneath f, and the borders of these areas are also written down here. And then w is bounded by a x equal to p, with p greater than 9. Then they say there's a certain value of p for which phi and w are the same. Well, let's see. What is the area phi? Well, that's the integral from 7 to 9 of this function here, of which we already know the derivative. So that's then log x squared minus 11x plus 30 between 9 and 7, which is log 9 squared is 81 minus 77, minus 99 plus 30, and minus this primitive at 7 is log 7 squared is 49 minus 77 plus 30 . 81 minus 99, there's 18 between, so it's minus 18 plus 30, is 2. A log of 2 being 49 is 77, there's 27, 28 minus 28 plus 30 something wrong here. No, this is 80. There's so it's very important to double check. This is 18 plus 30. So that's actually minus 18 plus 30. Which is 12. And this, what did I say? This is 2, right? So we get minus 28 plus 30. Oh, minus log 2. And this actually you can write as log 6, but let's keep that for now. Well, no, let's just write it as log 6. So this is again the primitive but now between P and 9. So that's log P squared minus 11P plus 30 minus the log of this whole thing at 9, but we already calculated that here that's actually why I kept the log 12 here, because it will actually drop this log 12. But anyway, we already know 9, it's log 12. And now we have to say these two are equal. Or, in other words, log 6 is log P squared minus 11P plus 30 minus log 12. Okay, so we can bring this bring this to the left side. So you get log P squared minus 11P plus 36 is log 6 plus log 12. So it's that's the product of 6 and 12. So it's log 6 times 12 is 72. Actually, I can also even bring this log 72. I subtract both sides by this, and then demand that this log is 0, but you get exactly the same result, namely that p squared minus 11p and then minus 36 minus 72 is 36, has to be 0. Sorry, this is 30 actually. So this is 30 minus 72 is minus 42. And what you use here is that if log A equals log B, that is equivalent with A is equal to B. Okay, so let's work this out. P squared minus 11p minus 42. P squared minus 11p minus 42 equals to 0. So let's see if we can factorize that. And let's look at the factors of 42. So 142, obviously, not 2, 21, 3 and 14. Well, 3 and 14 would add up in some way to 11. So that's 3 and 14. Let's try minus 3 plus 14. Well, no, that doesn't work. But plus 3 minus 14 works. So P is minus 3 or P is 14. But it is said here that P is greater than 9. So this drops out. So here we have a final answer. Question 3. We have the function gx is the absolute value of actually what function f in the previous exercise. And this function is symmetric in 5.5. And that is probably because at x equals to 5.5, this g of x is 0. And then you get this, what I call knikpunt in the function. Basically, the function is continuous in a, but the derivative isn't. And you can see at a it is 5.5, so you get, yeah, these two, so yeah, exactly this becomes 0 then, as drawn here. So it means that the slopes just to the left of 5.5 and to the right of 5.5 are different. Just as you will see if you draw the absolute value of x, which is a function like this. Oops. Okay. Here and in this point, you can also see a knikpunt. Don't know what the right word in English is, but the derivative suddenly goes from some finite negative number to a positive number. Okay. So let's calculate that, and then so to the left of a, this function is actually negative. You can just substitute a number, I guess, but you can also look at our f here. Oh no, so just to the left of 5.5, it is positive, and just to the right of 5.5, it's negative. So to the left of 5.5, we can use that g of x is, or let's say to the left of a, we have g of x is just given by the original function f, actually. And we know the derivative of this. Or no, we don't know it. We have to calculate the derivative of this. G prime of x is, using the chain rule again, minus x minus 5 to the power minus 2 minus x minus 6 to the power minus 2. And in particular, at g prime equal to 5.5, we get then is minus 5.5 minus 5, so 1 divided by 1 over 2 minus 1 divided by squared, of course, minus 1/2, or minus 1/2 squared, so that is minus 4. You can just multiply by the inverse of this, 1 over 4, numerator, denominator, and minus 4 is minus 8. So you have to know how to do these kind of things. So it's negative, what you expect, so that's the slope of this line here. Oops, draw it very poorly. Alright, that was not a success. Let me actually draw it here. So it's actually pretty steep. You can see it's minus 8, so one step to the right and goes 8 down. And the other rag line will be something like this, and then the angle they're asking for will be this. I have the smallest angle here. So what happens to the right of A? Well, then this, we just saw this is negative, so we need to have a minus sign in front of the function. So the minus sign here. So you get actually this minus sign follows through everywhere. So minus minus, this becomes two pluses, this becomes pluses. So what you get is basically from the symmetry that it's 8. And probably this notation is a little bit tricky. You're really approaching 5.5 because in A itself it's a knik which doesn't have a defined tangent. Okay, so what does that mean? So we know now what this, the slope is minus 8. So that tells us, so if this is the right, let's call it L, this is R. We know now what this slope is. And we also know, so let's call this alpha, and the one that we need to obtain is theta. We know that the tangent of alpha is then 8, so of the right line. That means that alpha is the inverse tangent of 8. So let's put that in the calculator. Or let's solve for tangent x is 8. Actually, this is in radians. Close this down. Approximate form to get something numerical is 1.45 radians. Alpha is 1.45. So let's put that into degrees. And for some reason they're asking that. Okay, I don't exactly know how to define a constant. Let's actually see what they're asking. Provide your answer in gehele graden, means the degrees and as a whole number. So we can just do convert this into degrees. So times 180 divided by 3.14. I probably should have figured out how to put pi in it, but this is accurate enough. That means, so this is radians, and alpha is 83.1 degrees. So let's keep the 1 here. And so this slope is, this angle here is of course the same, just a minus sign. And these are like opposite angles. So this angle is also alpha. And this is the straight angle rule. So you get theta is 180 minus 2 alpha. Alpha is 83.1 minus 2 times 83.1. It's 13.8 degrees. which probably might make sense. And they're asking to put it in a whole number of degrees, so it's actually 14 degrees. All right. Question 4. We have a rectangle ADEH consisting out of 3 squares, and AB is given as the factor 1, 0, and AH is given as the factor 0, 1. Now we have a segment AF and HD. Then they say these intersect at some point S, and they say that these are the coordinates, or this is the vector AS, and we have to prove that. Probably you can use some geometry for that, given there's a lot of symmetries, like triangles that are similar triangles, or something like that. But I guess in these cases, if it's still safe to do the brute force way, in case the geometric version is not that simple. And that will basically be being set up define the 2 lines AF and HD and just cross them. So point F, because we know point F here, which is 2, 1, and yeah, we have everything to determine these lines. So we can use the slope-intercept form of lines, or you can use the vector representation of a line. Actually, you can do both. So let's first write an expression for AF. So I will say this of the form mx plus b. The slope is delta y divided by delta x. If I go from A to F, so that is delta y is 1, delta x is 2, so the slope is 1/2. And the origin, what we define, the origin obviously is on it, so that means our line is just simply y is 1/2 x. Not too bad. Line HD will be a little bit more difficult. Again, we call this mx plus b, different m's and b's. And now m is minus 1/3. And we have that point H has to be on it, so H on line, that means 1 has to be equal to minus 1/3 x plus b, with x here in point H is 0, so it's actually times 0. So b equals to 1. So line HD is simply y equals minus 1/3 x plus 1. You can double check if you want that point F is on this line and point D is on this line. So if I substitute x equal to 3, yeah, I get 0. So now let's cross these. So we need to solve this set of equations. But from here I can just see that x is 2y. So let's substitute that here. Again, there are many ways to do this. I get y minus y equals minus 1/3 times x. With x equal 2y, so I get minus 2/3 y plus 1. So bring this to the other side. I get 1 plus 2/3, 5/3 y equals 1. So y equals 3/5. That looks good. That's just given here. And then x is 2y is 6/5. So let me also do it the other way, just as illustration. I just write line AF as basically the origin, since it's on the line, plus some lambda times, well, that's 2, 1. It's 2, 1. So that's our AF. Our HD would be H is on it, so 0, 1. But then plus some lambda times the factor from D to H, so it's D minus H. So, well, let me do D minus H is 0, 1. Plus lambda times the x coordinate is 3, for H is 0, so it's 3. The y coordinate of D is 0 and of H is 1, so it's minus 1. So now, where do they cross? So let's actually give them this parameter another name, lambda prime. These two have to be equal, so you get the two equations, 2 lambda equals 3 lambda prime, and lambda equals 1 minus lambda prime or in other words we can just substitute lambda in this equation or let's eliminate lambda prime. So we get lambda prime equals bring lambda prime to the left and lambda to the right, so you get lambda prime is 1 minus lambda. In other words, putting it back in equation 1, 2 lambda is 3 times 1 minus lambda. I put the lambda term to the left, so I get 5 lambda is 3. In other words, lambda equals to 3 over 5. This is 3. And then I just substitute it in AF to find the coordinates of the point. So I get lambda 2, 1 simply is 6 fifths, 3 fifths, which is what we have to prove. Question 5. Onderzoek, which means investigate if the vectors BS is given here and HD, the vector from here to here, are perpendicular, loodrecht. There might be some geometric way to find this out, but let's just like checking if a circle, if for example B, S and D are on a circle, which has to be have center C, then B, S and CD are chords of the circle, and if SC, this segment length, is also the radius, then by Taylor's this is perpendicular. But actually let's just do more easy and straightforward way. Just calculate the vector from that's pointing to D from B. Sorry, from H to D, and the vector from B to S, and then you take the in product and check whether or not they're perpendicular. So you know between two vectors, if the in product between two vectors is 0, it means they are perpendicular. So let's do that. The vector HD is D minus H 3, 0 minus 0, 1 is 3 minus 1, and the vector BS is S minus B, and for S we have the expression 6 fifths, 3 fifths, minus B is 1, 0. This is 5 over 5. Put it in equal denominators. So this is 1 over 5, 3 over 5. And calculate the in product, so you get HD in product BS. So you just multiply the x components and then add the product of the y components, so minus 3 over 5, 0. So they're perpendicular. Another way is to calculate the slope of HD and the slope of BS, and then the product of the slopes has to be minus 1. That is also something you definitely need to know and remember, and you should get the same result. Question 6, model tube. So they give a cylinder here with diameter 4 centimeter, and on the bottom you can squeeze it down to a linear shape. The height is 10 centimeters. Unfortunately, this is, I don't know why they do this, all these complicated word kind of questions. I hope you just try to get to the math as soon as possible. So from the bottom to the top you have, if you look at it from the top, you will have a certain cross-section, horizontal cross-section of this tube. And the height h is measured from the bottom, so this is h is 0, and to h is 10. We have 2 half circles and 2 parallel line segments. The circumference of each cross-section is equal to the circumference of the cylinder. So that will be 2 pi r, which is the circumference of circle of radius r. And since the radius is 2 centimeters, so it's 4 pi. So that's fixed here. Then the distance here is of course the diameter of these circles here, half circles here. And they call that d. And then how does d change? Well, they say that it changes linearly from 0 to 4. So linear means that h is, means that d is some constant times h. Since we know at h is 0, d is 0. And at h is 10, d is 4. So alpha is 4 divided by 10 is 2/5. Okay. Okay, what are they asking? The cross-section depends on h if you go from the bottom to top. So yeah, you can kind of imagine that actually the cross-section probably increases. You see at h is 0 it is even 0. And the volume of this tube will then be this integral here from 0 to 10 of this cross-section as function of h. And now they're asking, investigate if the tube can contain 80 centimeters cubed of the shampoo. Okay. So in order to do this integral, we need to know A of h. And well, let's calculate. Let's take a case here and first define this area here, which will be, say, the A areas of the circles, and then this area here, which you can call the area of the rectangle. So AC equals a pi r squared, which is pi times 1/2 d squared is 1/2, 1/4 pi d squared. But we know d is 2/5 of h, or factor 2/5 times h. So this is equal to 1/4 times pi times 4/25 h squared is 4/100 pi h squared, which is 1/25 pi h squared. And well, what about the rectangle? The area of the rectangle is just the width times the length. So that is d times the length here. Okay, so how do we get the length? Well, we know that the total circumference is 4 pi. So we need to demand that 2L then plus the circumference of these half circles with diameter d. With radius d over 2, it's 2L plus pi times d. That has to be equal to 4 pi. So 2L, 2 pi times the radius. That's correct. So that means 2L is equal to 4 pi minus d times pi or L is equal to 2 pi minus d divided by 2 times pi. But then we want to express it into h, right? We need to get a in terms of h. So this is 2 pi minus 1/5. So we have 2 pi minus 1/5 h pi for L. So with that we can find AR as D times L. So it's 2/5 h times 2 pi minus 1/5 h pi is 4/5 h pi minus 3/25. Sorry, 2. H pi. So the total area is these two combined. H squared. H times h. So this is 1/25 minus 2/25, so you get minus 1/25 h squared pi plus this 4/5 h pi, and this you have to integrate between 0 and 10. So we get for I we get the integral of that from between 0 and 10. And so the primitive of, so you have 1 pi h squared, and what do we have? Plus 4/5 h pi. Actually, you could put this in your calculator as well, since it doesn't have to be done exactly. But the primitives are not so difficult. The primitive, as you should know what the primitive function of x a is, right? That's 1/a plus 1 times x to the power a plus 1. So this is then minus 1/75 pi h to the power 3 plus 4/10 pi h to the power 2. And just in case, if you do the derivative, you should find the original function between 10 and 0. Well, let's put this in the graphic calculator. Minus 1/75 times pi times h cubed is 1000. 4/10 is 2/5 is 0.4, of course, times pi times 100. So that's 83.7 centimeter cubed. And they were asking if it can contain 80 centimeter cubed, so no, cannot contain 80 centimeter cubed. Question 7 about squares. So we have a function f given by f of x is e to the power x, and we have a point P here. P is greater than 0, and there are two squares, v and w, and you can define a ratio of these of the areas of these squares. And then they say there is a certain value of P for which R is a maximum. Okay, and calculate exactly, meaning that we have to do it analytically, what the maximum value of R is. Alright, what's area phi? This has sides phi, so that's just p squared. What's area W? Well, let's calculate one side. That's the side we know is it's the function value at p, so e to the power p. So that's e to the power p squared is e to the power 2p. So now we know what the ratio is. It's p squared divided by e to the power 2p. And now we need to find for which p this is maximum. So we just calculate as for r as function of p where the derivative is 0. And since it's given that it has a maximum, then we also should assume that whatever that p is a maximum, not a minimum. So this is a quotient of two functions, so we have the how you call the quotient rule for derivatives of the function that is a quotient of two functions. You definitely have to know this. It's g times f prime minus g prime f divided by g squared. You also need to know what it is of a product, by the way. So, well, what's r prime? R prime of p is then my function g times the derivative of p squared, which is 2p, and minus the function g prime. Well, use the chain rule. This is then e to the power 2p times the derivative of the function in here, which in this case is simply 2. Alright, that's not too bad. And then here we get the square of g, which is then e to the power 4p. This has to be 0. This thing is never 0, so we don't worry about that. We just set the numerator 0. And in the numerator you can factorize. There's a common factor of 2 times e to the power 2p. So we just write it as e to the power 2p times 1 p times p. It's still easy to make mistakes here, so just be really careful and double check everything with every step. So this means p has to be equal to 1. But they're asking what is the value of r, so that means r is just 1 over e squared, which is the final answer. Gelijke hoeken, similar angles. We have a line K given here. This kind of representation of a line you have to be familiar with, where you have like one point on the line as well as like the direction of the line. Okay, these two lines intersect in a point S. Now we also have a line M given here. We can choose A and B such that M cuts the angle of line K and L in half. And in this situation, A is 1/3/4. So what we can do is calculate the angle of each of these lines with M and demand that these angles are the same. And in that, if A is equal to this. So, since the directions are given by this factor 5/12 for line K and 3/4 for line L, 1/A for line M, we just need to calculate the angle between these. So if we have two factors, A and B, we use the in product to find the angle. So this is one required knowledge, the angle between A factor A and B, or the cosine of the angle, divided by the norms of these two factors. Sorry, what am I saying? That was embarrassing. The angle between two factors the cosine of, say, alpha is the angle, is the in product divided by the norms. This is required knowledge. So we apply that for K and L with respect to M. So the first is 5, 12, and the inproduct with 1a divided by the norm of this vector times the norm of the other has to be equal to 3, 4, 1 over a divided by the norms again, this norm is always not non-zero, so actually this will drop here, makes it a little bit more easy. So we get 5 plus 12a divided by 25 squared plus 12 squared. 25 plus 1, 44. 3 plus 4a divided by 9 plus 16. This is 169. What? Oops, I need to take the square root. Sorry. Fortunately, these numbers turn out to be numbers that have a whole square. So you get, I just forgot the square root, but this is, I use this, so this is 5 plus 12a 5 by 13 equals 3 plus 4a divided by 25. So you get 5. I make so many mistakes, so always double check everything while you're writing it down. So you get 25. Just multiply both sides by 5 times 13. So you get 25 plus 60. A is 39 plus 4 times 13 is 40 plus 12 is 52a. These things are always super error prone, so bring the a to one side, so you get 8a equals 39 minus 25, this is 14, so a 14 divided by 8, simplify, is 7 divided by 4, which is 1/3, which was basically what is being asked. Question 9. calculate exactly the value of b. So do it analytically. Well, we just need to figure out for which b this line m goes through S. So let's first calculate the snijpunt intersection S. So solve for 29 plus 5S has to be equal to 3t, and 4 plus 12S has to be equal to 24 plus 4t. Well, there are many ways how to solve this. You can multiply the first equation by 4 and the second by 3, and then subtract them. Actually, let me do that. First, probably rewrite it a little bit. 29 plus 5S and minus 20 plus 12S is 4t. So take multiply the first by 4, then I get 4 times 29. So 116 plus 20s is 12t, and minus, so 3 times 2, minus 60 plus 36s is 12t. You can also just solve for t here and substitute here, but then you get denominators and stuff. So let's now subtract these two, and you get 176, if I'm correct, minus 16s is 0, and let's hope that's a whole number. Ah, yes, miracle. So S is equal to 11, which means that, so now we substitute S here, get 3t equals 29 plus 55 is 84, which you can divide by 3, is 28. Well, actually, we probably didn't need to calculate t. We know that the intersection is at s equals 11, so we could have immediately calculate x and y. That's 29 plus 55, 4 plus 132 embarrassing. I still use my calculator because I'm lazy. It's 84,136. Alright, at least there are whole numbers. And now we need to find a b for which this line is on it. So this has to be equal to 0b plus some value of u. And what was a again? 7/4. So u is 84. And so b is 136 minus 84 times 7/14. Unfortunately, 84 divided by 14 is a whole number, right? It's 6. So it's 136 minus 42 is 96, right? 96. That should be the answer then. Double check. Probably in exam you should explain a little bit more what you do too in the text, because they will just see what you write on paper. There's something weird, because if I put b in here, it's 96. I don't think I will get. This will be 7/4, not 7/14. So you get 84 divided by 4, which is 21. Right, yeah, 21 times 7 is 147. So it's minus 11. So b is minus 11. And again, you can double check it, that this is true by the substituting your b minus 11 and the u 84. Verouderingskromme. All right, another word, these word questions. So this, actually I don't know how to say this in English, and it's a curve that is relevant for the decay of buildings. My God. They have a certain score, conditiescore, score, which tells you what the condition of the building is. And 6 is the worst. And 1 is if it's new. Then they have a certain model. T is the age of the building in years. and L is the theoretical lifetime of the building or the building part in years if you don't maintain it. And C is a number which is used to calculate the condition score. Say the 1 to 6 here. And they use this equation for C and T and L. And then they remove all decimals when they calculate C. They kind of round it down. Then the question for a certain building with a theoretical lifetime of 25 years, so that will be capital L, how many years it will take to get a condition score of 2 and provide your answer in 1 decimal. Yeah, so of all the long story here, yeah, the problem is you still need to kind of understand that the capital L is 25, and T is the age of the building which they are asking for. They're asking for T, what is T? For which C is equal to 2. I wish they just give you that equation and ask you to solve it, so you don't need to go through that wall of text here. But it is what it is. So we need to solve the equation (6 minus 5) 1 minus 1 divided by 25 divided by to the power of 1 divided by 2.3, and this has to be, oops, this is T, this has to be equal to 2. Okay. Actually, you can probably just plug it in. But let's manipulate it a little bit. So let's bring 6 to the other side. So you get minus 5, 1 minus T divided by 25 to the power. This is minus 4. Divide both sides by minus 5. So you get 1 minus 4 over 5. And now you can take both sides to the power 2.3, so that you kind of isolate the linear term in T. So you get 1 minus T divided by 25 is 4.5 to the power 2.3, and that means bring 1 to the other side. and then multiply both sides by minus 25, then you have isolated t. Minus 25 times 4 over 5 divided by 2 to the power 3 minus 1. So this you have to put in the calculator. Minus 25 times 4 over 5 is 0.8, 2.3 minus 1. That is 10.0360. So this is the time where it gets this condition score of 2. So that's, they say they kind of round it. No, we just say 1 decimal. That means answers then 10.0 years. So this, so after this 10 years, it will have, at 10 years it will have condition score 2. But actually, and your Dutch has to be really good, they're asking during how many years it will remain to have 2. So, given that it's always rounded down, it means that even after some more years, it will remain to have condition 2. And actually all the way until c reaches 3. So we need to solve another thing. We need to solve the same equation for c equals to 3. So 6 minus 5, 1 minus t over 25 divided by this power is 3. And you can actually do the same as I did for c equals to 2. But let's illustrate how you can immediately do this numerically. And again, in the graphic calculator, I don't have one, but you just need to set up this function and cross it with another function y equals to 3, for example. Okay, so you get 6 minus 5 times 1 minus t divided by 25 and to the power 1 over 2.3 equals 3. Well, let's see. 17.2 years. Oops. 70.27. Actually, let me also double check the result for 2. What do I get? solve it. Well, you see the crossing point is somewhere above 10, so I assume that answer on the previous calculation is okay. So I get the total time, or the time at C rounded down to 2 is then 17.27 minus 10.0. What did I say again about one decimal? So it's 7 or 2 years. So set condition 2 for 7.2 years. Okay, question 11. You can express the equation in this form, equation 2, basically where t is isolated. So then they're asking, question 11 actually, I did 10 already. You have to find what A and B is. I think we almost partially did that already in the previous, but now we keep L basically as a variable. So we solve we basically manipulate this equation C by isolating t. So the first thing we should do is move 6 to the right. We move 6 to the right and we divide by minus 5. And you get 1 minus t divided by L. Oh, that same power is C minus 6 divided by minus 5. We see our 6 minus C already occurring. And let's write this a little bit more pretty actually as 6 minus C divided by 5. So now we take both sides to the power 2 over 3 divided by 1. And if you do that, you get just 1 minus t over L on the left side. Right? You use a to the power b to the power c, a to the power bc. So you get 1 minus t divided by L equals 6 minus c to the divided by 5 to the power 2.3. Now I move my 1 to the left and multiply by both sides by minus L. So I get t minus L times 6 minus c divided by 5 to that power minus 1. So this has to be equal to this here. Well, let's rewrite it a little bit. Well, you can actually set this equal to here and find out what it is, but let's just write it as L. And here you see only 6 minus c to a power. So let's let's pull out this 1 over 5 to the power 2.3. So you can just use to some power. It's just 1 over b to that power times a to the power. So, and the minus sign, so I get negative 1 over 5 to the power 2.3 times 6 min c to the power 2.3 plus 1. Okay, so we also have the minus sign here, so that means that a is 1 over 5, so it's basically 5 to the power minus. Let's just write it like this. And b is 2.3, and you need to write this in 2 decimals if necessary. Five to the power minus 2.3. So this is equal to 0.0246, etc. Okay, question 12. Okay, a lot of wording again. They say that you actually can write it as this expression, equation 3, and they put them together with that earlier equation with the solid line here, this formula 3, and this is the lifetime of the building as a fraction of L, the theoretical lifetime, or I would say T is the age of the building as fraction of the total lifetime. Okay, then they say that according to equation 1, it reaches 70% it reaches condition score 3 at about 70%, or just before, probably. That's this point here. But for formula equation 3, that happens a little bit later. Will be this point. And now calculate when that happens as a fraction of capital L. So let's just plug it in. 1/2. The base is 1/2 of this logarithm, which is interesting. 1 minus t divided by L has to be equal to 3. And so this solve for t over L, and let's call that A. So I got 1/2 log 1 minus t divided by L equals, just said I can use A here. Is 3 minus 1 is 2. And I can just take 1/2 to this power on both sides, right? If some base to the power A is some base to the power B, that's like equivalent as A is equal to B. Oops. So I can just apply that for capital A and capital B being these numbers. And as the base I use 1/2, so I do that, I get 1 minus A has to be equal to 1/2 to the power 2. Well, that is 1 over 4. So A is 1 minus 1/4 is 3 over 4. So you have to exactly calculate it, so that's exactly 75%. Question 13. Cosine graph through maxima or something. Well, let's see. There's this function fp of x, and p is in this range interval, and x is in this interval, and it is drawn for certain values of p. And it is said here that f3 has, except for the origin here, also a second common point x-axis here. Okay. And calculate exactly the x-coordinate of this common point. So let's set this function equal to 0. For p equals to 3. So let's just obviously you can see this is a quadratic equation. We know how to solve these, so let's just define a u as cosine of x and figure out what u must be, from which you can find what x should be. So this is minus 2u squared plus 3u minus 1. Let's see if we can just here I would just write it as with a positive coefficient of the square term and see how if we can write this in some formula like this. There's actually a systematic way to do this as well, but trial and error, or you can put it in a graphic calculator. Let's put a minus 1 here, so I get minus 2u, and a minus 1 here, and I have it. So u is 1/2, or u is 1. So where is the cosine of x equal to 1? Or let's start with 1/2. Well, remember your standard angles. That's really important. It comes over and over. It comes back. Again, I guess you can put it in the graphic calculator and just figure out what it should be as well. So from this we get x equals at 60 degrees, so 1/3 of pi plus 2n of pi, with n a natural number, any natural number. But we are in this domain, so n is 0, so we just have x 1/3 pi, and u is 1, so this is 1/2. U is 1, means the cosine of x equals to 1, which basically means x is 2n pi, and that in this domain means x is equals to 0, but that's the one they already stated. So the second common point or intersection of the x-axis is this one. Question 14. So this function fp has a maximum. For p is 4, it is in point x is 0. For other values of p, it also has a maximum. In figure 2, they indicate with a thickest tip, which is just a dot, the maximum of fp. So for p equals to 4, it is here. For p equals to 3, it is here. P equals to t, it's 2, it's here, etc. Then they say that the x-coordinate a of the maximum of fp, for that maximum we have this equation. Cosine a is quarter of p. Okay, let's find what it is. So the maximum is in where the derivative of the function is 0. So minus 2 cosine squared, wait, let's first write an expression for the derivative. So f prime of x is minus 2, our good old chain rule. You get 2 cosine of x to the power 1 times the derivative of cosine, which is minus sine of x. Remember, the cosine is going down at 1, so you can remember that you need that minus sign there. And again, this is just a simple derivative, minus p times sine x. Okay. So substituting a, we need to find 0. Well, let's just keep the x, it doesn't matter. Set this, we just say f x is 0. So you get minus, or actually plus 4 cosine x sine x minus p sine x is 0. Let's factorize the sine of x. Again, don't divide by sine x, because sine x could be 0. So you get sine x times 4 cosine x minus p. Let me see if this. Alright. It should be. Is 0. So either sine of x is 0 or 4 cosine x minus p is 0. Well, where is the sine of x 0? In x equals to 0 or x equals to 1/2 pi. Sorry, x equal to pi. And you can see from the form of the functions, all the slopes here are horizontal. And if p equals to 4, actually both here are 0. If x equals to 0, which is shown here. So it's given that only for p is 4, from the expression of g, you can see that it's actually outside of x equal to 0. if p is not equal to 4. So for sure then we have cosine of x is p over 4. Question 15. They say that a curve that connects these maxima is given by this expression gx is cosine 2x in this interval. Alright, well we just calculated, where is it? Right here. We know that the maxima are at these values for which cosine of A is a quarter p. So what is the y value of the maxima? We need to figure out the y value of the maxima. So fp of A is minus cosine squared A plus p cosine A minus 1. But we know that cosine A is a quarter p, these for the locations of the maxima. So we just substitute this for the cosine square, and this is equal to 1 over 4 squared is 1 over 16 times minus 2, so I get minus 1/8 p squared plus a quarter p squared minus 1, and this is was plus 1/8 p squared minus 1. And remembering that how does A come into this? Well, basically A is the cosine inverse of 1 over 4p. And we just can substitute it back to get a functional expression of p in terms of A. So this is 1 over 8 and times 4 cosine A squared minus 1. And this is 2 cosine A squared minus 1. And this is, if all is well, going back to the equations given here, this is exactly the cosine of 2 times A. Question 16. I didn't really want to clear that and do. Okay. Right, we have these equations of motions. They describe a parabola. Then we have a point M, R0 is a point on the positive x-axis with R greater than 1/2. Now we pick a point A, square root of A, on the parabola. Such that this line MA intersects the parabola perpendicularly. And then we have to prove that A is equal to R minus 1/2. Okay, well, we know. So what we would want to find is figure out this slope here, so that we can then define a line define the line going through A and M, find the slope, and demand they're perpendicular. So we have xt is t squared, and we have yt is t. So, which means if we just look here at y larger than 0, we have y is the square root of x. So let's call that h of x. And the derivative is 1/2 x to the power minus 1/2. So in particular at point A, we have then that it's 1 divided by 2 times the square root of A. And just assume here that A has to be greater than 0. Except potentially in the origin, but that probably won't happen. Let's check later. Okay, now let's look at this line AM. Well, what is the, and let's calculate the slope. Delta y is just square root of A, and delta x is R minus A. And we know that the product of the slopes of two perpendicular lines is -1. So we get square root of A divided by R minus A times the slope of line H is -1. These drop, multiply by R minus A both sides, so you get -1/2 equals minus R minus A. that's not exactly. Let's see. What did I do wrong? This is all correct. This is my delta y. I calculated, so here you just have to be a little bit careful. I want to take point A and point M, and I want to calculate ym minus ya divided by xm minus xa, and I think I flipped these here. What I get is actually a minus sign here, because ym is 0, and I need to subtract y of a. And indeed, r is the x of m, and then minus a. So yeah, so there's a negative sign here. So what did I do? So there should be a negative sign here. So I get minus 1/2 is minus r plus a. So a is r minus 1/2. Last question 17. We have a circle here with radius r, the center m, and if line AM crosses in a point B, then A is right in the middle between M and B. So that will mean that the point B here is like an equal distance from A as point M is from A, and the same for the Y values. So we can say that Bx is A, then minus this distance here, which is r minus a. So that is 2a minus r, and a is r minus 1/2, so it's 2 times r minus 1/2 minus r is r minus 1. That's the x coordinate of b, and the y coordinate of b is a. No, not a, it's the square root of a, which is the y coordinate of a, plus the distance from a to the vertical distance from a to m, which is again the square root of a. So it's 2 times the square root of a is 2 times square root of r minus minus 1/2. Okay, good. And now we just need to say that this has to be on the circle M. Now what's circle M? It's all the points given by the equation x minus r squared plus y squared equals r squared. Okay, so let's substitute what we have for x and y. So you get r minus 1 minus r squared plus that thing squared. Or let me just immediately write it out. That's the square of this, right? Equals r squared. So let's just work away all the brackets. This is 1 plus 4r minus 2 is equal to r squared. So r squared, bring all these to the right, minus 4r minus 1 plus 1 equals to 0. Now that the factors of 1 are 1 only, so there's not much we can do to factorize it simply, but we can try to I call it split the squares. So we can write this as r minus 2 squared and make it minus 2 to get, if I work this out, I get minus 4r. I get the r squared, but I also get a 4, which I need to subtract. So minus 4 plus 1 equal to 0. And that means r minus 2 squared 3. One other way is actually just still use your graphic calculator and try to, from what you get, try to estimate what actually the precise exact value of r is, or just use this equation with the discriminant to figure it out. So get r is r minus 2 is equal to the square root of 3. That's a squared is equal to b squared. That's equivalent. If a is b or a is minus b, this is one of the algebraic skills you need to know. So I need to apply it myself correctly too. So plus or minus square root of 3. So r is 2 plus the square root of 3 or 2 minus the square root of 3. There are actually two solutions. but we r has to be greater than 1/2. So we can eliminate this solution. So we find r is 2 plus the square root of 3, which finally completes the exam.